Hi everyone. So we learned that a vector is a mathematical object that has both magnitude and direction. In this video, we're going to discuss how we can represent these vectors by drawing them. So one can represent a vector graphically with a little arrow, like this one. So the length of this arrow, right, so how long it is going to tell us the magnitude, which is why often we also just refer to it simply as the length. So length and magnitude are going to be synonymous when we're talking about vectors. So how long is this guy? This guy looks like he's about an inch long, at least on my computer screen. And he points in a certain direction. And the direction that I draw my arrow is going to correspond to the direction of the vector. So pretty straightforward. If I want it to be representing something to the south, then it needs to point towards the south. Of course, drawing it on a piece of paper, you're going to need to just tell me which is north, south, east, west if you're doing that. But in general, the direction of the arrow is going to just correspond to the direction of the vector itself. Now, this is all that we need to specify a vector, right? Magnitude and direction. So the specific location I draw the vector, whether I draw it here or over here or up above or wherever I draw these vectors, it doesn't matter, right? A vector is defined simply by having a particular length and a particular direction, and that's all the information you need. So we can compare different vectors to each other. So this green vector that I've drawn here, it's a different vector, right? It's longer, it has a different magnitude, but it appears to be pointing in the same direction as the pink vector. And so therefore we would say that these are parallel vectors. They are different in length, but they have the same direction, therefore they're parallel. These two vectors, on the other hand, they appear to be about the same length, but they're pointing in different directions. So these vectors, we would say, have the same magnitude. And then finally, we might also discuss anti-parallel vectors. And so these two guys, again, they have different lengths, so they have different magnitudes, but they are pointing in exactly opposite directions, which is what it means to be anti-parallel. So these are sort of different ways we could talk about how different vectors relate to each other. We could also talk about the negative of a vector. So two anti-parallel vectors that have the same magnitude, right? Here, these guys had different magnitudes. Two that have the same magnitude and are anti-parallel, they're said to be the negative of each other. So if this is our vector, which I'm calling vector A, and this is my vector, which is vector B, we see it's pointing in exactly the opposite direction, and they have the same length here. And so I would say A is equal to negative B, or I could also say B is equal to negative A, right? They're just the negative of each other. And again, where I draw these vectors doesn't matter, right? It doesn't matter where they are relative to each other, only how their lengths compare and how their directions compare. So again, just to really drill this in, the location of the vector in space doesn't matter, only its length and direction. So vector A and vector C are pointing in the same direction and have the same length. And so therefore, we would say these two vectors are equal, right? A is equal to C, even though they're in different locations, because a vector is simply defined by its length and its direction. All right, so that's the basics of how you can draw a vector.